Okay, so let's look at number 15. We have the limit of x minus 9 over 3 minus the square root of x as x approaches 9. So the first thing that you want to try is direct substitution. If you were to plug this into the denominator, you get 3 minus the square root of 9, which is 3, and 3 minus 3 is 0, so that does give you division by 0. So that means we have to do some kind of fancy factoring. In this case, what do you think we should do? The conjugate. So we need to multiply by the conjugate of the denominator. In this case, it will be 3 plus the square root of x over 3 plus the square root of x. Great. Okay, so now at this point, what I'm going to do is I have a fraction times a fraction. So what I'm going to do is just combine it into one complete fraction, which I have there. So all I did was just combine the top for both and then the bottom for both. Now, only this time, I think that your best bet will probably be to multiply the denominator out, because you notice that it's going to be a perfect square. So let's go ahead and multiply that out. Well, if I multiply it out, on the bottom, all you have to do is just first times first. So what's 3 times 3? 9. And then you have second or last times last. So you have a negative square root of x times a positive square root of x, which will just be minus x. So your next part will look like this. So you're left with x minus 9 over 3 plus the square root of x over 9 minus x. Now here's the tricky part, because some of you all sometimes when you're in a hurry, you want to go ahead and cancel this one out with this one, but they are not the same. When they're not the same and they look kind of similar, that most likely should be a clue to you that you probably need to factor out a negative somewhere. And in this case, it really doesn't matter where, as long as you stay consistent with it. In other words, you bring it along every time and not forget about it. So just because I want to arrange it the way that we're used to seeing it, I'm going to factor out a negative from here, from the denominator. So when I factor out the negative from the denominator, I get the following. I get x minus 9, 3 plus the square root of x. And then if I factor out the minus, I'm left with x minus 9. How do you know if you factored correctly? Multiply the negative back in. So what's a negative times x? Negative x, which is right there. And what's a negative times a negative 9? Positive 9, which is right there. At this point, now you can cancel. And what cancels out is the x minus 9, which I will highlight in red. So then you are left with basically the limit of 3 plus the square root of x over negative 1. At that point, direct substitution does work. So if you direct sub the value of 9 into the function, you have the square root of 9, which is 3. 3 plus 3 is 6, divided by negative 1 is negative 6. And the limit of negative 6 is negative 6 as my answer. Let's look at number 16. You have the limit of 7 minus x over x squared minus 49. As x approaches 7, if you attempt to substitute 7 into the denominator, then you get division by 0, so that means that you have to do some fancy factoring. In this case, if you realize your denominator is a perfect square, so you know that they're going to be the same, except for that one will have a positive and one will have a minus. So if you do factor correctly, you should get the following right there. So when you factor, You have x plus 7, x minus 7 in the denominator, but you still have 7 minus x. However, don't cancel anything out because they look similar, but that usually means that you most likely have to factor out a negative, which I did in this case right here. I factored out a negative, and when I factored out a negative, I got x minus 7. How do you know if you factored correctly? Multiply back in, negative times x is indeed negative x, and negative 7 times negative 7 is indeed positive 7. Now at this point, your x minus 7's cancel, which I will go ahead and cancel out. And so you're left basically with this part right here, which is negative 1 over x plus 7. Direct substitution works because now all you have to do is plug in 7 plus 7, which is 14, and your numerator is negative 1. So you have negative 1 over 14 as your answer. Number 17. Number 17 is a little bit tricky, but you should know what the graph of an absolute value function looks like at this case. So let's take a look at it. Let's see. Let me show you a picture right quick. Okay, so when we're discussing limits of an absolute value, let's see if I can find a better one. I don't think I can find a better one, so we'll deal with that one. Remember that when you're discussing limits of absolute value, you have something like this where, remember, you had two cases. I know we've done an example like this. For example, we've done the absolute value of x over x, and your two cases are it's positive x if it's approaching from the right-hand side. So if you're approaching from the right-hand side, you're left with just x over x, which is just 1, which is this portion right here. If you're approaching from the left-hand side, then you take the negative value of that case, so it would be negative x over x, which will be a negative 1, like this, and it is a open circle. So if you think about it, this kind of discontinuity, because it is discontinuous, is what? Let's review. What kind of discontinuity is this? This is a jump because there is a break in your line. So if you think about it, remember last year that we discussed that if there is movement going on inside with the x, it always shifts your function the opposite way. So it's always going to shift it. For in this case, the minus 2 really will shift it to the right 2 units. Well, either way, if you shift this to the right 2 units, you're going to have the exact same thing, only right here at x equals 2. Therefore, your limit will still always be does not exist, because if you approach from the right-hand side and if you approach from the left-hand side, you're still going to get different values, and they're going to be 1 and negative 1. And I will go over that case with you tomorrow. So for this one, it will be does not exist. I actually need to be there in person to show you. What I can do is I can actually show you the positive one. Well, let's go ahead and do it. So it might take longer. So before I even do this, let's approach from the right-hand side. So everything to the right-hand side is a positive value. So what we can do is we can drop that. So insert, let's see. So I'm going to take the limit from the right-hand side. Okay. So if I approach from the right-hand side, I'm assuming that the value will be positive, so therefore I can just drop this and make it x minus 2. Well, x minus 2 over x minus 2 will simply just reduce to 1. So my limit from the right-hand side will be positive 1. Well, if I approach from the left-hand side, that's that second case where this will be negative. Okay, and if you reduce this, these two cancel out right here, which will just leave you with negative 1. Therefore, your limit overall does not exist. So you could have done this by hand, or you could have actually just punched it into your calculator and noticed that the graph has some discontinuity and your limits from the right-hand side do not match up with the limits from the left-hand side. Okay, so let's look at number 18. Eighteen says the limit of x squared minus x plus 5 over x minus 3. Let's see if direct substitution will work. So let's plug it into the bottom. Negative 3 minus 3. Will that give us division by 0? It won't, so therefore I can go ahead and direct substitute. So let's go ahead and plug it in. So equals so for this one, I will have negative 3 squared minus a negative 3 plus 5 and negative 3 minus 3. Okay, so at this point, let's go ahead and just simplify. So on the top, I get a negative 3 squared, which is a positive 9. This minus a minus 3 becomes a plus 3. And then I have plus 5. Okay, this negative 3 minus 3 is what? Negative 6. So this part is a negative 6. 9 plus 3 is 12. 12 plus 5 is 17. And 17 divided by negative 6 is already simplified. So my answer is negative 17/6. Okay, any questions on that one? Let's move on to number 19. Number 19 says limit of 3 over x minus 1 minus 3/4 over x minus 5. Okay, it looks like this one is a common denominator one. And what you're going to do is you're going to take the common denominator of your two fractions in the numerator. So what I will do is I will multiply in a fancy way. And notice that direct substitution didn't work in this case because if you were to plug in 5, you get 5 minus 5, which is 0. So my fancy way of multiplying will be 4 times x minus 1 over 4 times x minus 1. Okay, so let's see what's going to happen. I distribute this to both terms in the numerator. So let's look at this first term. I have x minus 1. That will cancel out with this x minus 1, leaving me with just the